Okay, moving on to problem solving using those unit conversions we were just talking about. So there's a great four-step process that's laid out right here for you. So step one is state the given and needed quantities. Step two is to write a plan to convert the given unit to the needed unit. Step three is to state the equalities and conversion factors. And step four is to set up the problem to cancel out those units and calculate the answer. So this is where it's going to be helpful that I said, the flip-flopping will actually make sense. This is where this is going to start being applicable. Okay. So, again, the guide to problem solving using conversion is the process of problem solving in chemistry, and this often requires one or more conversion factors to change a given unit to the needed unit. So the problem solving requires identification of the given quantity units, the units that are needed, and then also the conversion factor that helps to connect the given and needed units. Okay, so again, I read those steps out to you, and we will see how this works. All right, so if a person weighs 164 pounds, what is the body mass in kilograms? So let's step back. Step one is to state the given and needed quantities. We were given the weight in pounds, and we need it in kilograms. And so step two, let's write a plan to convert the given unit to the needed unit. Okay, so 1 kilogram equals 2.2 pounds. So again, we can do that, the flip-flop guide. And then we're going to set up the problem to cancel the units out. So you see that if pounds is on the top for one side, we want pounds on the bottom for the other. So this is how, when I said we can flip-flop and it's the same, this is where it comes into play. So we want 164 pounds, and that would be over 1 if you wanted to. You don't have to. Okay, but then we would cancel out pound and pound, and then we would times 164 by 1 and then divide it by 2.2, and that gives us 74.5 kilograms. Double check your sig figs, 3, 3, and then 3. Okay, so that's that application of what we were talking about and how we can actually utilize it. Okay, so let's practice on your own. So a rattlesnake is 2.44 meters long. How many centimeters long is the snake? So set it up. What were we given and where do we have to go? So with this, the rattlesnake, again, was 2.44 meters long. How many centimeters long? So we're going to be given the meters and we need centimeters. And so what are we going to have to do? We're going to have to convert the meters to centimeters. Well, what was the formula for doing that? 100 centimeters equals a meter. Okay, so that's how we're going to state the equalities and conversion factors. And then we have to set up the problem so that the units cancel. So we want 2.44 meters is what we are given. We want meters on the bottom so that those two can cancel each other out. So what we end up doing is 2.44 times 100, and that gives us 244 centimeters. And again, double check your sig figs. We had 3 sig figs. This is an exact measurement, and so we need to give the answer in 3 sig figs. Okay. So what happens when we have to do this more than once? So 2 or more conversion factors are often needed to complete the change of units. To set up the problem, one factor follows the other. Each factor is arranged to cancel out the preceding until the needed unit is obtained. Okay. So if a doctor prescribed, a dosage of 150 milligrams of Synthroid, if the tablets in stock contain 75 mcgs of Synthroid, how many tablets are required to provide the prescribed medication? What? Okay, break it down. What are we given? Okay, we are given that we have 0.150 milligrams of Synthroid, and we need the number of tablets. So let's write out a plan. We're given milligrams, we need to go to micrograms, and then we need to go to the clinical factor, the number of tablets. All right, so let's set it up. All right, So 1 milligram equals 1,000 mcgs. Okay, and then the tablet equals 75. So we have two different equations, and this is how we can set it up to into one big one. Remember, we need to cancel those measurement units. So milligram on top here cancels the milligram on bottom here. MCG on top here cancels the MCG on the bottom there. And then the unit that we're ending up with is tablets, because that was canceled out by that. That was canceled out by that. The only one that's not canceled out would be tablets. Okay. And so what we'd end up doing is 0.150 times 1,000 times 1 divided by 75, and that would give you 2 tablets. Okay. And since we go to the lowest denominator, that would be 2 sig figs, but it ends up being an exact number. Okay. So that would be your 2 tablets. All right. So let's try it. How many minutes are in 1.4 days? Okay, we're gonna again write a plan. Always write out this plan. I know it sounds silly, but as these get more complicated, it's gonna help you out a lot. Okay, so let's write this plan to convert the given unit to the needed unit. So we have days, which is a time factor, hours, which is also a time factor, to give us minutes. Okay, so state the equalities and the conversion factors. 1 day equals 24 hours. Okay, 1 hour equals 60 minutes. Set it up so that we can cancel. Days cancel days. Hour cancels hour. We're ended up with minutes. And what do we end up doing? 1.4 times 24 times 60, okay, divided by 1. And then that gives us our answer. And then we have the two significant figures from the original. So that's why we end up with 2.0 times 10 to the third minutes. Okay. All right. And so here is another one that you can work on your own. If you place a treadmill in 65 meters per minute, how many minutes will it take you to walk a distance of 7.4 kilometers? I think. Okay, so we'd have to set up the problem again. We have 7.5 kilometers. 1 kilometer equals 1,000 meters. That times 1 minute equals 65 meters, because that's what it told us. Divide it out, and that would be 115.38 minutes. All right, I hope that this was helpful. I'll see you in the next video.